Very good morning to all of you. I'm Dr. Neetu Gailor. I'm working as assistant professor in St. Andrews Institute of Technology and Management, Gurgaon. I'm from Applied Science Department. Today, I'm taking my 16th lecture, and in this lecture, um, I delivered some topic. These are the ionization energy, electron affinity, and the polarizability. These are the parts of our first unit and the chemistry. So, um, so uh, as we know that the today's topic which are uh, delivering by me. These are the ionization potential, ionization energy, electron affinity, and the polarizability. First of all, we are going with the ionization energy. So here, first of all, we should know the ionization energy. What is ionization energy? So simply, when an electron lose or remove, and the energy which is required for that process is called the ionization energy. So simply, we can say that the ionization energy give a measure to the case with which an atom can lose an electron and change into the cation. When the atom loses the electron, then it converts into the cation. And the ionization energy of an element is defined as the amount of energy required to remove the most loosely bound electron from an isolated gaseous atom. Here we can say that here is the one isolated atom is M, and this is the ionization energy, and this atom goes to the convert the cation. It means there is the lose the electron, and this is the energy which is called the ionization energy, which is required energy is called the ionization energy. And now the ionization energy is also called the ionization potential, because it is measured as the amount of potential needed to move the most loosely held electron from the gaseous atom. Okay, तो conditions क्या है कि एक तो isolated या gaseous atom होना चाहिए, and the unit of the ionization energy is the kilojoule per mole or the electron volt per atom. अगर छोटे में लेना है तो electron volt per atom and the kilojoule per mole. Now the second is the successive ionization energy. It is very important, successive ionization energy. And here the atom may not lose one electron, but more than one electron also. ऐसा नहीं है कि केवल एक इलेक्ट्रॉन को लूज करता है. So not lose one electron, there are the more than one electron also. But it is essential to specify the definition of ionization energy for each electron which is to be removed. So the energy required to remove subsequent electrons from the atom in the gaseous state are known as the successive ionization energy. And here the term first, second, and third are the more ionization and more ionization energy refer to the removal of first, second, third, or more electron respectively. And which means the for first electron, the first ionization energy, the second electron, second ionization energy, and for third electron, the third ionization energy. So their change may be represented as the follows. So here we can see that at first we can see here the it is the first ionization energy when the atom goes to the convert into the cation, and it means the M positive in the gaseous state. So the first energy is called the first ionization energy. And when the cation all again lose the electron, so it means now the energy is called the second ionization energy, and again it is called the third ionization energy. So hence the ionization energy first, ionization energy second, ionization energy third represent first, second, and third ionization energies respectively. Okay, For example, the first and second ionization energy for lithium. So here the example of the lithium, we can see that the lithium in the gaseous state, now it converts into the ion, it means cation, and here the electron, and the first ionization and the ionization energy is equal to 520 kilojoule per mole for first electron, and now the lithium positive, it goes to lithium 2 positive. So the second electron loss, and the ionization energy for second electron is the 7289 kilojoule per mole. So here we can see that the second ionization energy is more, much more, not more, is much more than the first ionization energy. है ना? So we can see the second ionization energy is much more than the first ionization energy. So this is mainly due to the fact that after the removal of first electron, the atom change into monovalent positive ion. भाई एक इलेक्ट्रॉन रिमूव हुआ तो पॉजिटिव चार्ज हुआ और कैसा हो गया मोनोवैलेंट आयन. So in the ion, the number of electron decreases, but the nuclear charge remains same. So the remaining electrons are held more tightly by the nucleus, and now it is very difficult to remove the second electron. Okay, and so the second ionization energy is greater than the first ionization energy, and so for the third ionization energy is also this type. So we can see that the ionization energy increase here. So the factors which affect the ionization energy, or we can say that the factors on which the ionization energy depends. So these factors are firstly the size of atom. Here ionization energy, we know that the ionization energy is inversely proportional to the size of atom. Ionization energy, it depends upon the distance between the electron and the nucleus. That is, we can see that is the size of atom. Okay, so the size of the atom increases, the outermost electron are less strongly attracted by the nucleus. Clear? Because the force of attraction is inversely proportional to the square of the distance between the charged particle. So it becomes easier to remove the electron, and therefore ionization energy would tend to decrease with the increase in the size of atom. Clear? Now come to the second point, that is the electronic configuration. It is very important point. So according to the electronic configuration, or we can say it is the electronic arrangement. So the ionization energy also depend upon the electronic configuration of the atom, or it has been observed that the certain electronic configuration, certain electronic configurations are most stable, are very, very stable than the others. So here we can explain with the help with the example. So then for half filled and the completely filled shells have the extra stability associated with them. Okay, so it is difficult to remove the electron from these stable configuration. So the ionization energy is high. Here are the some points that the first is the noble gas. In the noble gas, so there is the highest ionization energy because the octet is complete in the noble gas, and वहाँ पे कोई इलेक्ट्रॉन का लेना देना नहीं है, so it means the ionization energy is very high. वहाँ से निकालना आसान नहीं है. And in the case of this second point, that is the, here we can see the electronic configuration of the B is the 1s2 2s2, and for the Mg is equal to 1s2 2s2 2p6 3s2. So we can see that they are the fulfilled. Both conditions are the fulfilled. So the ionization energy is too high. And now the third point, here we can see in the case of nitrogen and the phosphorus. So we can see here the electronic configuration of nitrogen is 1s2 2s2 2 2px1, 2py1, 2pz1. Z1. It means the 3 electrons are present in the p orbital. Okay, 2p orbital. And for the phosphorus, here we can see 1s2, 2s2, 2p6, 3s2, 3px1, 3py1, 3pz1. Here we can see that again 3 electrons are present in the 3p orbital. So we can, as we know that these are the half filled, because in the p orbital there are the maximum number of the electrons are the 6. So now there are the only 3 electrons in the p orbital. So it is the half filled, and as the half filled orbital, so it means the stability is high, and the ionization energy is also high. Clear? Now come to the third point, that is the charge on the nucleus. Here we can see that the ionization energy is proportional to the nuclear charge. Or here we can say that the attractive force between the nucleus and the electrons increases with increase in the nuclear charge. So because the force of attraction is directly proportional to the product of charges on the nucleus and that on the electron. So therefore, with the increase the nuclear charge, it becomes more difficult to remove an electron, and ionization energy increases. So this is the charge on the nucleus. Now come to the next point, that is the penetration effect of the electrons. है ना? Penetration effect क्या है? It means we know that the s electron are the more penetrating towards the nucleus, क्योंकि सबसे पास वही होता है ना? Then p electron and the penetration power decreases in the given shell in the order SPD and F. Okay, तो S की सबसे ज्यादा, P की उससे कम, D की उससे कम और F की सबसे कम. Now we come to the variations in the ionization of the ionization energy. So here, as we know, variations are the two types. The first is the along period, means left to right in the periodic table, and down a group. The left to right or top to bottom. So firstly, we goes with the along a period. It means the left to right. So in a period, the ionization energy increases. We know that the increasing atomic number in a period. So this is the quite clear from the values of the ionization energy of the secondary element. Okay, and on moving across a period from the left to right, we know that the nuclear charge increases, and if the nuclear charge increases, it means the ionization energy is also increases. Okay, and the atomic size decreases along a period through the ionization, through energy level remains the same. So we can see that the nuclear charge increases, so the ionization energy is also increases. And when we goes to the down a group में जाते हैं, ऊपर से नीचे आते हैं, तो here we can see the size increase होगा. Okay, so then we can see that the within a group the decrease in the ionization energy in moving from top to bottom. Yes, why? It is clear from the ionization energy value of the element of the first group, as we know. So in going from top to bottom in a group, the nuclear charge nuclear charge increase. Okay, and this is a gradual increases in atomic size due to the addition main shell. So we can say that the atomic size increases here and the ionization energy is decreases here. So along a period, it increase from left to right, and down the group it decrease from top to bottom. Another one exception, one or many or other exception cases here, that the in the case of nitrogen and oxygen, so the ionization energy of nitrogen is high in comparison to oxygen. Give the reason. The reason is that because in the nitrogen we know that the atomic number of nitrogen is 7. So here the 3 electrons are present in the 2p orbital, and in the case of oxygen there are the 4 electrons in the p orbital. So we can see that in the nitrogen there are the half filled. There is half filled orbital, and in the due to the half filled, or it means there is the high stability. so that the ionization energy is also high here. Okay. Now second topic is electron affinity. देखो, the amount of energy released when an electron is added to an isolated gaseous atom. पहले हमने क्या किया, इलेक्ट्रॉन को बाहर निकाला इन आयनाइजेशन एनर्जी, एंड इलेक्ट्रॉन एफिनिटी में इलेक्ट्रॉन को अंदर लाना है. सो अमाउंट ऑफ एनर्जी रिलीज्ड, इस टाइम पे जो एनर्जी रिलीज होगी व्हेन an electron is added to an isolated gaseous atom is called the electron affinity. Or we can say that the amount of energy released when an electron is added to an isolated gaseous atom is called electron affinity. Clear? Yeah. When an electron is removed from an atom, energy is required for the process of removal of electron, but energy is released when electron is added in neutral atom. Clear? So there we can see that this is the X is the gaseous atom, and here is the electron. Electron को अंदर लाना, so it means it can now if the electron is comes with the atom, so it means it have the negative charge. Okay, so now the energy is called the electron affinity. Okay, and let's take the example of Cl. So Cl in the gaseous state, electron is here. Now it gives the Cl negative, and it is the energy. So if an atom has more tendency to accept an electron, so large energy will be released. Consequently, electron affinity will be high. So on the other hand, if an atom has less tendency to hold the electron, small amount of energy will be released and leading to a small value of the electron affinity. So electron affinity, it may be positive or may be negative. So when energy is released during the addition of an electron to an atom, the electron affinity is taken as the positively. The unit of the electron affinity is the kilojoule per mole. क्लियर है. सो इलेक्ट्रॉन को अंदर लाने के लिए जो जितनी तो खुश होगा वो ज्यादा और एनर्जी रिलीज होगी, तो दिस एनर्जी इज कॉल्ड द इलेक्ट्रॉन एफिनिटी. नाउ द फैक्टर्स on which the affinity depends. So here are the some factors. First is the nuclear charge, as we study above in the ionization potential, that the electron affinity is proportional to the nuclear charge. Okay, then come to the size of the atom. So here we also know that the electron affinity is inversely proportional to size. जैसे size बढ़ता जाएगा तो electron affinity कम होती चली जाएगी. Now the third point is the electronic configuration. So here the element having stable configuration as same as the ionization potential. So here the element having the stable configuration of half and the full field valence subcells show very small tendency to accept additional electron. I repeat again, the element having stable configuration of half and the full field valence subcell show very small tendency to accept the additional electron. So the electron affinity are low or almost zero in the certain cases. Yeah? So now come to the variations of the electron affinity. So firstly goes along a period, and second down a group. So here the first we goes to the along a period. Okay, along a period, it means the we goes to left to right in the periodic table. So we can see the nuclear charge increases, and the nuclear charge is we can say that is the Z, or number of proton increases, so that the electron affinity increases here. Okay, now come to the down a group. So here the atomic size increase, so the electron affinity decrease as same as the ionization potential. Now this is the successive electron affinity, and in the ionization potential it is the successive ionization energy. So here now come to the successive electron affinity. that is the like ionization energy, the second and higher electron affinity are also possible. Clear? So here the example of the oxygen in gaseous state and the electron and oxygen is the oxygen anion, oxygen negative charge. So the electron affinity is, firstly the electron affinity is plus. Okay, so it is a plus 140.9 kilojoule per mole. तो बिकॉज यहाँ पे क्या हो रहा है कि एनर्जी रिलीज हो रही है, ठीक है ना, तो रिलीज हो रही है तो हमें मिल रही है, इट मींस द पॉजिटिव चार्ज इज देयर. एंड इन द second step, it means when the this oxygen anion goes to the O2 negative, so it means अब इसमें क्या होगा कि नेगेटिव ऑलरेडी ये है, so इसमें से इसको इलेक्ट्रॉन देना और ज्यादा मुश्किल हो जाएगा. Clear? So the for O negative is convert into the O2 negative, so it is difficult. So here the energy हमें डालनी पड़ेगी. First, in the first case energy released है, and in the second case energy required है. So that required energy, it is as the negative sign is. So electron affinity 2 is negative value is 770 kilojoule per mole. So remember that the first electron affinity is positive charge and the second electron affinity is negative charge. Suppose और आगे निकालना पड़े तो it is very difficult. Okay, so in other words, the second and the higher electron affinity would have the negative values. So this is the electron affinity. Now come to our third topic of today's lecture, that is the polarizability. It is very short topic, polarizability, and there is the definition, and I can explain it here. Now the polarizability is the measure of how easily an electron cloud is destroyed by an electric field. ठीक है, हम लोग कहते हैं कि इलेक्ट्रॉन के क्लाउड के फॉर्म में है. So how can the electron cloud is destroyed by the in electric field? Of course, the electron cloud would remain with an atom or molecule or ion, कुछ भी हो. So it is only destroyed from its original position. So the electric field could be caused by an electrode or a nearby cation or anion. Suppose हम कह रहे हैं कि हमारे पास एक cation है और एक anion है. So the size of the cation is very small and the size of the anion is large. So due to the effect of the cation, and all the electrons of the anion are goes to the cloud is goes to the near to the cationic part. So it means the cation has the polarizing power. The polarizing power is the for the cation, and polarization किसका हो रहा है? That means that यहाँ पे there is a formation of the pole. These are not the pole, but they convert into the polar. So that the power, polarizing power of cation and the polarization of anion here. So the induced, here we can see that is the ion induced dipole and is the dipole induced dipole. So the induced dipole moment is related to the polarizability of the molecule or atom and the strength of the electric field by the equation, that is the equation polarizability is denoted by alpha is equal to P upon E. So P is represent the induced dipole moment and E is represent the strength of electric field. So here the factors that influencing polarizability, the greater the number of electron, the lesser control by the nuclear charge or charge distribution, and thus the increased polarizability of the atom. And again the polarizing power of the cation and the polarization of anion. Okay, so the greater the distance of electron from nuclear charge is less controlled by the nuclear charge on the charge distribution and thus the increased polarizability. Molecular orientation with respect to an electric field can affect polarizability. Such like species are the orientation dependent, but the molecules that are just like the tetrahedral, octahedral, so are the orientation independent molecule. So their polarizability is not affected. So these are the topics which are covered in this lecture. These are the ionization. First topic is the ionization energy. I hope you understand all. And second is the electron affinity, and the third is the polarizability. So here the one question that explain the the ionization energy of nitrogen is greater than the ionization energy of oxygen. So now I stop my lecture. For any query, you can contact with me. Thank you so much.